Hi, example 9 in exercise 7.03 uses effective interest rates to compare offers. So the actual question says, Ella is saving for a new car and wants to invest the money she has saved in an interest-bearing deposit. She is offered the following rates from different banks. So offer 1 is 5.4% per annum compounding weekly. Offer 2 is 5.3% per annum compounding daily. And offer 3 is 5.6% compounding monthly. So which offer will give Ella the best return? So we're going to use effective interest rates to do that. So let's start with offer 1, and we'll use the same formula for each one. It is the effective interest rate 1 plus I over n to the n minus 1. I'm working in columns again because I like that. Now I is equal to the interest rate as a decimal, so that's 0.054, and I is equal to the number of compounding periods. So n is, in this weekly, is 52 weeks in 1 year. So let's just put that into my calculator, or the formula first and then the calculator. 1 plus 0.054 over 52 to the power of 52, and then remember to come out and subtract 1. Come out of the brackets and the power. Alright, so if you put that into your calculator, you'll get the effective interest rate of 0.0555, which is 5.55%. Okay, pretty good. A little bit more than 5.4. So let's have a look at offer 2 and see whether compounding daily makes a difference. So we'll write out the formula again. Only this time in offer 2, the interest rate is 0.053 and the offer is compounding daily. So that's 365 days in 1 year. So I to the e is equal to 1 plus 0.053, the interest rate is a decimal, divided by the number of times it's compounding in the year, 365. Take it to the power of 365 and subtract 1 at the end. All right, that's after you've taken it to the power. So if we put that into your calculator, you'll come out with the resulting number of 0.0544. which gives you an effective interest rate of 5.44%. Okay, interestingly, you would think daily would give you more, but it's a slightly less interest rate. So weekly at a slightly higher interest rate gives you better. So at the moment, offer 1 is looking good, but let's check out offer 3. So I'm going to slide slightly to the left so I get a little bit more room there to write. Okay, so again, the same formula. We're practicing that formula over and over again, although I believe it is on your sheet. Check it out, make sure it's the same as what we're using here. I to the effective interest rate, now I in this case is equal to 5.6, the highest one of the options, but let's see, because it's only compounding monthly, so n is going to be 12. Let's see if that compounding monthly has any impact on the higher interest rate of 5.6. I to the e, let's put it all into the formula, 0. Oh, that was meant to be as a decimal place, but we can do that now. Over 12 to the power of 12 and subtract 1. Okay, when I put this into my calculator, I to the e is equal to 0.0575. So that's the equivalent of 5.75%. So if you were going to write this up as an answer, I'll just see if I can slide that in. You can see here if we're, these are the values that we're comparing, offer 1, offer 2 and offer 3. So this was Ella. I didn't have the whole question in the top there, but Ella should invest her money in offer 3 at 5.75% effective interest rate. Whoops. So that to get the best return. So really you can see it is a combination of interest rate and the periods that it is compounding that make a difference.